What's up, pre-calc peeps? I am here just to show you an application of some of the properties that we have in pre-calc. Now, toward the end of the semester, we're working on odd and even, some co-function properties, and there's going to be things called the linear combination and composite and double argument. And they're all meant to just be curious consequences and properties like identities that are true about pre-calc. We'll focus in on these composite ones, and I'm going to take a snip of this and take it to a problem on, for our packet, it's page 24, where we're going to solve an equation right here. This is page 24. Find the simplified general solution and the particular solutions on the given domain of this equation, sine of 3 theta cosine theta plus cosine 3 theta sine theta equals radical 2 from 0 to 360, one turn of the wheel. So this is kind of meant to be a hint on this one. It says apply the composite argument property. Well, we have different composite argument properties that most of the time, if you have something that resembles things on the right, you can simplify them into something on the left. Or if you're doing something like, say, you want to find the cosine of 15 degrees, we don't have anything that in the unit circle that is helpful there, except we have the cosine of 45 minus 30. And then you can apply, going forward, a composite argument like this cosine one. So right here, it's good to kind of recognize the theme of that. And overhead, I'm going to write down the A's and B's of this one. This is the sine of 3 theta, I'm going to call it A. Cosine theta, I'm going to call that B. Plus cosine 3 theta, that's A, sine B. We are in the form of sine A cosine B plus cosine A sine B, where A in this case is 3 theta and B is just theta. That can be condensed into the sine of 3 theta plus 1 theta equals radical 2 over 2. And those are like terms. We're looking to solve the equation, the sine of 4 theta is radical 2 over 2. A much more tractable equation than how it was presented to us initially. We could, like, this was easy. We know that no, I wouldn't say easy, but with something like this sine of 4 theta, we can analyze the amplitude, the period, the phase shift and vertical shift. But here we are just solving it. Let's unwrap that. That means 4 theta is arc sine, of radical 2 over 2. We've been doing a lot of these with the calculator, but this is an angle that we should know from the unit circle. We would need the angle that has a sine of radical 2 over 2. That's going to be 45 degrees. Or in this case, yes, we're in degrees, so that is 45 degrees. However, there's also another one that is also 45 degrees. So let's say, I'll do the first branch, 4 theta equals 45 degrees plus 360 degree n, or 4 theta could be equal to, let's see, what is that other angle that also has a sine of radical 2 over 2? That is 135 degrees plus 360 degree n. Now it should be kind of automatic. We've done a lot of this. We've isolated the variables. In this case, it's theta. So that means theta equal to 45 fourths plus, let's see, 4 goes into 360, 90 degrees. Or theta equals 135 over 4 plus 90 degree n. And that should be a hint that early on, this original equation, sine of 4 theta, the period was 360 divided by 4, or 90. That's helpful. We know we're on the right track. Let's see, I'm going to clean this up. Theta 45/4 is like 11.25 degrees plus 90 degree N, or 135 cut into 4 is 33.75 plus 90 degree N. I put a box around that because that's my general solution. Those are the two ways to get every single possible solution to that equation. But now that we are in, we're looking from 0 to 360, you could do it several ways. You could make a table and find out how many, which values of n get you within 0 to 360. I just graphed that, put it on Desmos, and I'll give you I went from 0 to 360, and my y's were from -1 up to 1, because that amplitude was just 1, and here's 0, and it went through, this is a sine curve, let's see, I think it's something like that. This is a rough whoop, 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 something like that. We wanted to find out when the sine is radical 2/2, and that happened four places. 1, 2, 3, 4. Oh wait, you know what? I think there might be 8 places. Maybe I didn't finish it. Are there 8 places? I'm so sorry, I'm not sure. I know that to get you started, this one here is 11.25 degrees. That matches this one. And then 90 degrees later is going to be 101.25. And now this angle here is 33.75, and then 90 degrees later is going to be 123.75. I don't have a calculator with me. I believe there are four more solutions that are just 90 degrees apart from this 11.25. So maybe when n is 2 and 3, you'll get those remaining 4, and we would put it into theta equals 11.25, 33.75, 101.25, 123.75. I believe there's 4 more before we get to 360. But that gives you an idea of how we're using composite formulas and for sine, cosine, to make something easier and then solve it the way we have been practicing in pre-calc. Yay! Have fun. Thanks for watching.